The diagram below shows the first 4 diagrams in a sequence of regular hexagons. Oh yeah, I'm giving you credit for the word there, you know, I need the credit. Right. Each regular hexagon is made using sticks of unit length. Unit length means represents 1. Whether it's centimeters, millimeters, miles, feet, but we don't care the actual type of unit. It's a type of measurement, just so that it's 1 unit. Unit represents 1. Okay? Diagram 1, how many hexagons do we have? 3.
5.
Then diagram 2,
5.
increase by 2. 5. Then increase by what? 2 more, which is 7. Note what I'm saying when I say increase by 2. That's going to be critical or crucial later. Again, this one increased by 2 more to what? So we have 3, 5, 7, 9. Okay? It's a complete diagram below to represent diagram 5 in the sequence of regular hexagons. So, CXC recognize the shape might be a little difficult to draw, so they gave you a head start. Well, we had 3, 5, 7, what, 9? So this one should be what? 11. Okay, remember the hexagon has what sides? 6. I should go back to the other one. Let me see. If you recognize something as well, it has 1, everybody watching? A ratio of 1 to 2 here. Then the ratio of what? 2 to 3, 3 to 4, 4 to 5. That's what I recognize when I was seeing these as well. So I don't just look at 7. I see 3. Sorry, I see, this is not 7, sorry, this is 7, sorry. I see 3 on top, 4 below. But 9, I see 4 on top, 5 below. So based on that, when I go to mine, this will be what, 11?
Yeah.
So this 5 is already to the below, but 5 was below up there before. So that means what? I need 1 more for here, right?
Make it 6 underneath and then 5.
Right, 6 underneath. Oh man, ugly drawing. Yeah. And then I need 1, 2, 3, 4, 5, 6. How much I need on top? 3 more, well, 5, very good. All of you are correct, good. Good, so it should be 1, 2, 3, 4 more. Okay? And then let me see if I get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, I keep saying 9. 11, sorry. So I have my 11. Do that quickly for me, please. Those who don't have the paper printed, guess what? You have 11 to draw. Sadly.
That's okay,
That's okay, I'm enjoying it.
Everyone
I don't even want to picture them while I draw.
it's not good. No, we can have a hexagon, remember that.
Okay? So CXC worked with you and gave you a head start. Some examples you have to draw the full figure 4. Right? But for this figure 4 or this pattern 4, they started you off. Okay? So we want to take a picture of that, it's up to you because I'm not going to be dwelling on this for long. Right? The number of regular hexagons, H, number of hexagons, see that H, this is it, this column. The number of sticks, see there, S, this column. And the perimeter of each figure P, here, perimeter, follow a pattern. The values for H, S, and P, H, S, and P for the first 4 diagrams as shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. Complete the rows marked Roman numeral 1, Roman numeral 2, Roman numeral 3. Okay? So we're cooking on gas. I must say this. Every figure or pattern, that number is crucial. Now, normally when we look at this, right? If I look at the board for me, please, so wait a second. You see this word, diagram 1, diagram 2, diagram 3, diagram 4? That is not there by chance. That is not incidental and it's not here haphazardly or whatever. It is here for a purpose. Some people say diagram 1, some say figure 1, some say another word, whatever. Or pattern 1. That is crucial. I want you to understand that. We're going to be using those numbers here, pattern 1, diagram 1, figure 1, 2, 3, and 4, in our quest to find out how much hexagons we have. So see the first diagram, the first column here. Diagram number. Everybody done that this? Pass for a second, let them take the table. So, what we do for this has bearing for all the other question 7. Now this is a nice easy one to start it off with, which I was so glad for. Because we always started with May 2024. One has to listen carefully. What is the difference between 3 and 5?
2.
Right, so as we were saying, we added 1. 2. Is there a common difference? Can you say a common difference?
2.
Yes, do that for me please. We are increasing by 2 each time. Yes? Correct. So the obvious that this one will be what? 11. Excellent thing. So now, you should always look for a pattern. The thing about these questions, they tell you to find the pattern in the end. But if you can find the pattern from the beginning, everything becomes easy. It's a trick. They let you do things early o'clock and see if you can recognize the pattern. But I will advise you, see if you can find the pattern early. If you can't find the pattern early, don't let what the bar do. You see increasing by 2, just put it every day. That's the problem.
Yeah, but when you reach 2, you got to find pattern to figure out 2.
Well, yes, see, the problem will come here now, why? Now, look here. Now, this is what something I'll tell you, that ball. Shake out that ball. Right? Now, remember I told you the diagram number means something? That 2, you're going to take it. Let me explain something first of all. Whenever you see this, what comes to mind?
2. Counting in 2s.
You're counting in 2s, right?
Yeah.
Ignore even numbers for now, okay? And odd numbers, okay? May I ask the question? 2 times 1 is what? 2 times 2 is what?
4.
2 times 3 is what?
6.
And 2 times 4?
8.
So what do you recognize? In terms of multiplication and addition, what do you recognize?
The diagram. Where you come over there?
Yeah, everything.
2 times number.
Whenever I'm adding 2, I'm doing my 2 times tables. You see me again there? Whenever I'm adding 2, I'm dealing with my what? 2 times tables. So whenever you see you're adding 2 here, look at this. 2 times 1, right? 2 times this 1 here. Don't put this one out. 2 times 1 is 2. How can I get 3?
Plus 1.
Plus 1, right? Good. Let's see if we get the same thing here. 2 times 2 is what? 2 times 3 is what?
6.
Everybody see the formula now? So the formula for over here, give me a formula using n. 2n plus 1. Everybody see that? So whatever you're adding with, if this was increasing by 3, What would you multiply the diagram number by?
3.
I say, if I have 6, you multiply by the number.
3.
Say that it's happening. Come on, guys. 3, let's go. If you are adding by 3, then you are multiplying by what? 3. Your 3 tables is a repeated addition, you know? You ever heard of multiplication is repeated addition? So when multiplication and addition is not different. Multiplication is the shortcut for addition. Instead of me adding 7 times, the simply do what? Say 7 times 7 is what? 49, am I agree?
Yes.
You use the finger 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Can you reach 49? That's a waste of time, okay? Alright, let's go. So we recognize that the pattern of adding 2 gave us to multiply by 2. Then we found a number that can help us to reach the actual number. So in some cases, it will be plus 1. In some cases, it might be plus 1. 2. In other cases, it might be minus 1 or minus 3. You understand? Just multiply by the number and then see how do you reach the next number using either addition or subtraction. Good. Good. So, if this is the formula for here, can we find here?
Yeah.
Come on. Right. So this and this supposed to be what? What do you do that? Equal. You see that? So 2n plus 1 equals 47. Next step.
2n equals 47 minus 1.
2n equals
46.
a half of 46.
23.
You know, you can skip out divide by 2, right? CXC allows you to skip out. Like what you're saying, 2 times what is 46? 2 times 23 is 46. You get? But for the ones who don't like to see it that way, and you prefer this, I'll do it for you, okay? Anyone go on. So n here is 23. Let's look over here now. What's the difference? The difference is 8. Let's say that works. Let's say that works. 8 times 1. How can I get 15? Plus 7. Okay. Let's see if it continues. 8 twos. 16 plus 7. Okay, good. So 8 threes. 24 plus 7. 31. And 8 fours. 32 plus 7. So, did we find the formula? What you going here then? Eric, go ahead. What do you think going here? What formula going here? 8n plus 7. How did we get the 8? The difference between all of them coming down. Very good. In higher maths, they call it the common difference. Okay? And if you did not know the common difference, you still could have add 8 to here to get what? 8 plus 39 is what? 8 plus 39.
47.
47. All remember, you have a difference of 2 each time. 5, 3, 1. You see that? 9 and 7. That's how I know to multiply by my 8 type tables. Where I know that this is 39. In the higher register, I'm going to 2 less. 47. So I put 39, I put 49, take off 2. Okay? Good. But then again, you can still check. 8 5s are what? 40 plus 7. So you have 2 ways you could find that. Bada boom. Okay? Let's back check with this, that's for fun. 8n plus 7 equals 191. Next step. This is back checking, you don't want to do it. So you don't find it. Okay? 8n equals 191. Go on, which is? 184. Good. 18 to 18, I know. 18 to 18 goes over 10. 2 times. 5, which is 18 to 24 goes 3 times. Yeah. Good, so 23. Like I said, that's just back checking, okay? Why do you think I want to back check this? Why do you have to back check sometimes in the exams? Just to make sure you got the right formula. The formula must work all the time. If you work it all the time, if you only work for 2, something wrong. Formula must work all the time. And then lastly, what we have over here? Oh, there's what? Plus what? Plus 4. Plus 4. Sorry. Okay, so what's the thing the formula will be? 4 times 1. 4 plus what?
8.
Good. Let's see if it works. 4 2s. 8 plus 8. 4 3s. 12 plus 8. Okay, should I go further? So what the formula is?
4n plus 8.
Alright, good. I think this could be written a different way too. You see 4n plus 8, you pull up the 4, n plus what? 2? 2, but 4 2 is 8. So these two are similar, whichever way you prefer to see it. Okay? If you still put in the number here, let me see, put the 11 here. 11 plus 2 is what? 11 plus 2, 13. You see? What do it? 11, what's 11? What is 11 for? No, sorry. 5, sorry. 5 plus 2, sorry. 7, 4 7s. 28. You see that? So any one of these formulas could work. And by the way, before I start the camera, what did I do here? No. How did I get this formula done here? You factorize. 4 and 8 are a common factor, which is what? 4. Yes, 2 is a common factor, but we need what? Highest common factor, which will be 4. 4 2 is good. 4 2 is 8, 4 n is 4 is good. You said 36? But tell me why you get 36 here. Calculator? But let's see. No, I don't know the answer. Remember the answer. But it's not 36. It's 100. So what are we supposed to do? Tell me. Use the what? Formula? Okay, so which formula are you going to use? This one or this one? Which one I want to use?
Anyone?
This is the bottom one, okay? At this end, 23. 23 plus 2 is what? 4 times 25? 100. So, chase up is 100. Okay, let me see. There we go. Let's go. Skylar says, come together for 2, 1, 2.
Skylar says that she can make one of these figures with the numerator of exactly 1005.
Explain why she is
incorrect.
Which color is perimeter? This one?
Yeah.
The last one? So what's the formula we had for this one? I don't know about the book. Am I wrong?
4n plus 8.
Okay, 4n plus 8. So 4n plus 8. Skylar said that she can make one of these figures with a perimeter exactly that. Well, you don't find, so you don't waste the time doing this, but that's for fun. Alright, 4n equals 1005, take away 8. 4n equals what? Somebody help me do quickly. Come on. Huh? 997. Can 4 by do that evenly? No. So,
So you just put on upfront.
249.25. So that's proof, that proves currency. Right. And you can see it's only one mark. Right? So you just show that it doesn't go into the pop. Yeah, it's not divisible. Okay. No, every 5 is not divisible by 4. Not divisible by 4.
Equally.
Divisible.
By 4 equally.
It's a divisible, it means equally, yeah. Good God, teacher, good God.
So, I can put not equal.
Hey, good night. Been a while.
I can put not equal.
Put not divisible by 4.
Suppose we remember that.
Then walk it down, then show you.
So we must put that. Okay.
Hey.
Me put one remember, you hear me?
As you're writing down, I'll read. The diagram below shows the first 3 shapes in a sequence, which forms a pattern. You really need to use diagram 1 now? What do you use? Shape. Remember, those are important. Shape 4, shape 3. Those are very important. Don't take them for granted. Each shape is made using a set of small white counters and black counters. What you should be able to do, if you look at the black, how many rows do you see?
3.
How many rows?
2.
2. How many rows do you see for the white? 2. The difference is though, this row only has in 1, this has in 1.
3.
Which is what? 2 more. Never forget that, it's 2 more. 1 to 3 is a difference of 2. This is 2 times 3 is what? 6 or something like that? We have 3 rows, 3 rows. Both of them are 3 rows. This is increasing 1, 3, 5. Okay? What's the total? You see 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. From 4 to 9. This is how. This is 2 times 3, 6. This is 3 times. 3 times what? 5. 3 5s are what? 15. So this is, let me see, 15. This is what? 9. This is 4. 1, 2, 3, and 6. Rows now. 1, 2, 3, 4. 1, 2, 3, 4. 4 times what? 4 times 7. 28. And what we have here, 7 plus 5 is what? 12 plus 3 plus 1, 16. Look at the top numbers. That you should recognize something right off the bat. Look at these top numbers. Recognize those numbers? 1 times 1 is what? 2 times 2. 3 times 3. 4 times 4. Those are square numbers. Let's see this is a square number too. 1, 2, 3, 4, 5, 6, 7. This is the same thing now? This is the same thing? You look so, I think. Oh, this is the same thing. Right, so. You have to add others to this, right? So if this is 16, what do you think this is going to be now? 25. I have to recognize square numbers when I see them.
That's 2, that's 3, that's 4, that's 25.
Right.
2 times 2, 3 times 3, 4 times.
Let's look down here now. 6, 15, 28. The difference between this and this is what? 7? No. 8, 9. The difference between this and this is what? 13? Now look at the pattern for the follow. 2 to 3. Well, how will you get the bottom one? Tell me.
45.
Well, we had 3, 5, 7. So this is supposed to be what? We had 3, 5, 7. This is supposed to be what?
9.
Why?
I added 2.
Right. Okay? So well, this increasing by 1, 2, 3, 4, 5. So I'm gonna 1, isn't it?
Yeah.
You see all recognize patterns? 2, 3, 4, 5. And then I come in 3, 5, 7, 9. Yes, ma'am?
You put in one of the row,
Column.
one of the row on each side. So instead of putting both rows on there, you put one on each side.
That's true, you could do it that way.
Yeah. So you get the same item for the top. That's if you put it like that, you get 2 blocks out of the way rather than having it aligned.
Oh, okay. Good call, good call. I think you might have gonna work still, eh?
You have to add on the next side. No, you shouldn't work. You have to just add on
I
the
think you might have work, but anyway, I prefer what she says. So let's go.
Easy that way.
Yeah, easy this way, anyway. Good. So add on what for you?
1.
Just 1?
Yeah, so go up on each side.
On each side?
Yeah.
You do it too, you do it too.
You don't do it.
Thank you. You see that? You got your elbows up. Pass it. Your elbows up. Okay, there are many ways you could do that, okay? Alright, so now as we have that, we're gonna move to the table. No, this table you complicated it. Alright, the number is alright. The number of white counters W, the number of black counters B, and the total number of counters T that form each shape follow a pattern. Okay? The values for WB and T for the first 3 shapes that are shown in the table below. Okay? This is the pattern here. Study the pattern of numbers in each row of the table and answer the questions that follow. Woman numeral 1, complete the rows back 1, woman numeral 2, woman numeral 3 in the table below. More complex, a little more involved, but sometimes these formulas, right? You have to give them a chance. Sometimes these formulas are the better formulas because they're easy to follow. Look at the shape number for 1, look at number of white counters. You realize, you see, 1 plus 1, 2 times 1 plus 1 equals 6. Have I said that?
Yeah.
Make it a bit bigger. What's the difference now? Look at 2. Everybody look at 2. What's the difference? What is changing in all of these? So this 1 became a 2, because this is a 2. Good. And then look at the 1, 2, 3 here again. 1, 2, 3, 1, 2, 3. Okay? So these change, this does not change. This change and the plus 1 does not change. You see that? So from that you could follow the pattern then. Also look over here the number of black counters. Look at what is changing. The first number in the bracket is changing, not the second one. Okay? So those are things you look for. So when this formula look complicated, it's actually easier. It is commonsensical how it is laid out, the pattern follows. Okay? So, based on this now, let's use what we're not going here. Somebody, look again.
4 plus 1 square equals 5.
Good, because you'll be 5 squared, which is 25. I see that? Good. I want to be done here. Somebody help me out. Start me off. Oh, wait, we got nothing for there yet, right? Okay, good. Yes, we got it. But this is the easy one. Remember I told you earlier, class, we call these numbers. Guys, we call these numbers square numbers. What is a square number? And everybody who left primary school now, what give 144? 12 times 12. Okay? So obviously, the shape number will be what? 12. Another way to do it, well, what squared give you 144? The square root of 144 is 12. Okay?
It's 12, right? Yeah? 11, because 11 plus
Oh
1.
yes, oh good, yes. Good call, good call. So then we want the question one, okay? Good. N plus 1 square, good. So, yes, 144, but still, n plus 1 is 12. And then n plus n plus 1 equals 12. Good. 12 take away 1. Good call. It's 11. So when you wash it too much. 11. And then from that, if you're in the second or third row, you talk. The first row, be quiet. What are you here?
11.
Okay, so if you're in the third row, talk please, let's go. What are you here?
11 plus 1.
Hey, can they see? You're in the third row. Open bracket, 11 plus 1, close bracket, parentheses, 2, I can hear it, open bracket,
11 plus 1.
close parentheses. What do you get? Well, this give you 12. 12 times 22. 22 plus 1. This is together. So 12 times 23 is what? Anybody?
76.
276. Good. I know you're going to jam up, but let's work with it, okay? It's a long process, okay? Shakira, you see? Right? So 2 times 11 is 22, plus the 1. 22 plus 1 is 23. The 11 plus 1 is 12. The brackets mean to multiply 12 times 23 to 76, okay? Now this is the total. You have total counter. So 6 plus 4 is what? 15 plus 9. 28 plus 16 is. So what is happening here? Right, so this was 6 plus 4. This is 15 plus 9. 28 plus 16. It's going to be what?
44 plus 25.
That's 44. Look.
45 plus 25.
45 plus,
25.
which is what?
70.
70. Okay?
I use the formula, no?
Oh, what formula you have for you?
Yeah, formula to the bottom.
Oh, okay. It's off the screen. Okay. Can you give me the formula then? Give me the formula.
3n after that.
Ah.
3n squared plus 5n plus
Yes. 5n plus. Or the gain in the formula, is it?
Yeah.
Okay, good. So, n will be what? In this case, what? 4?
Yeah.
3 times 4 squared plus 5 times 4 plus 2. But because somebody who... Pam, help us with this one. 4 times 4. Get calculator, get calculator quick, get calculator quick. Get the calculator quick. Come on. 4 fours, yes. Good. 5 times, sorry, 3 times 16. Huh? 3 times 16. No. 48. Okay, let's do it yourself, guys. 5 times 4. Okay. And 48 plus 20. Plus 2. Good. So you see, you have multiple ways to do it. But show now you talk about this and this now. You must see that? So you have multiple ways to come back, check yourself, okay? Yes. Okay, I wanna make sure everybody have this. Can we take a picture now? But I can't scroll down. I can't, you can't go with it, scroll down.
You finished it, I went and I'm top.
The end. Yeah, you finish now? Picture? Good. I got to the board now, right, guys? Everybody with me? Everybody need a second to write this? Pause it quick. There's some people that don't write this. You gotta read again. No. Let me know what's doing this. You can't was not there. Get it again.
The expression for the total number of counters, T equals W plus B in shape F, is given by T equals AS squared plus BS plus 2, where A and B are both positive integers. By substituting suitable values for S, show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by the equations A plus B equal 8 and 3A plus B equal 40 respectively.
That's it? Alright, pause it. Okay guys, let's go. So, the number of white was 6. The number of black was 4. 6 plus 4, as we did previously, gave us what? 10. Total of 10. This S represents shape. But some suitable values for S. S is what? Shape. So that the total number of counters is shape what? 1. So if we use this formula here now, right, we know the total was 10 again. A, we don't know. But we know it was shape 1. We square in shape 1. We have B. We don't know what. We know this is shape 1. We don't know what B is. Plus 2. But we can use a different color for the A and B. Right? I'm going back over again. Watch. They said, they said these two are the same. We know from shape 1, if you go back in the table, shape 1 is the first one. Yeah. We had 6 white, 4 black. The total became what? 10. They said use the same formula, these two are the same. S represents shape. So wherever you see S, you put what? 1. Right. So now let's finish off this now. This is going to be 10. It's going to be what? A. 1 times 1 is what? 1 times A is A. B times 1 is what? B plus 2. Can we go any further? Continue. 10 minus 2 gives you what?
A plus B.
10 minus 2 gives you what?
A plus B.
Am I seeing that on the board anywhere?
Yes. Yeah.
Let's say try it now. Try it with shape what? 3. Do that for me now. Try to shape 3. Same exact thing. As a quick recap is that this formula and that formula, they say it's the same. Right? This is shape 1. It's saying 6 counters, white counters plus 4 white counters give you 10 total. If this formula is the same, we recognize that they say S represents shape. As somebody's mentioned, if you can find it in the table. And it also mentioned shape 1. So you look at shape 1. So shape 1, that's where the 1 come from. The S represents shape 1. S squared is 1. Well, 1 squared is 1. 1 times A is A. 1 times B is B. The 2 carry over. We end up with 8 equals A plus B, which is that. But this one now a little more involved. This is shape 3. So wherever you see S, you put 3. You recognize that this is 9A. This is 3B plus 2. You carry over, blah, 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 you end up with this. And then we recognize that this and this doesn't look the same, but they are similar to each other. Where this is a factor of this, and this is a multiple of this. And we have an example here. Where equations can have factors, and equations can have multiples. So as a result, we reduce this by 3, divide 3 into all 3 terms. And up 3 times 14 is called 2, 3 times 3 is 9, 3 times 3 is 1. And then you end up with what they gave you in the first place. Okay? And above. Let's go. As you can tell, it doesn't have the word shape, it doesn't have the word diagram, it doesn't have the word figure. They have what now? Design 1. Does it change anything? No. Okay? It's still the first diagram. The second, the third. Let's look at some patterns. We have 2 black. We have 1 black, 3 here. We have 3 here, but 4 this way. But this is a connector. So 3, 4. Or I want to say 3. I don't know how you want to say it. We have 2 plus 1. We have 2 times 3 is 6 plus 1. We have 3 times 4. So this is 1 times 2, 2 times 3, 3 times 4, and this plus 1 all the time over there. So find things that you could find patterns with, okay? So you think the 4th pattern will be? Might want to cut to the 4th pattern, come on, man. Anybody want to do the 4th pattern quickly?
Yeah.
You come. Get the car driver. Yeah. That should be easy. No. The second close here. Yeah. Excellent. If I see the next Tikemadi exams, take a people on the paper. Okay? Thank you. Give a clap. Alright. Can't do it any better. When you recognize the trick with these two, if you're okay, skin it out, if you're smart, draw back this and then just add on. So if you draw back this and you got the white here, then you just darken it and you just increase accordingly, okay? That's just one of the sequences you could do. Okay? Come into the picture that guys can have to clean the mood. Come. This one is a quick one, guys. So let's go. Then move on to the table. Start doing the table now, please. Start to get your table out to do it. You have it? Okay, good. Thank you, sir. Keep that anyway. Alright, good. Anything missing on? Again, remember these formulas work well with us, eh? Remember? They look confusing initially, but when you watch it, it's very easy to do. Okay? So, quickly. This one follows what? This one, this two, this three follows what? The design number P. Good. This also follows the design number P. This also follows the design number P. Just the last one is constant. So do that quickly, please. What are here? 9, 9, 1. Now, if I fail that here, I need to stick. Let's go. 91, 81.
Plus 9.
81 plus 9. 90, 91. Excellent. And let the people go ahead. Very good. Now look at this one here now. From the first one we did, what's the pattern? Who can tell me?
Plus 2.
Plus 2. What do you say about the plus 2? What we use it for? Okay, let's go. So 2 times 1 is 2. How do we get 4? Plus 2. Let's see if that works for all. 2 times 2. Plus 2. 2 times 3. Plus 2. 8. So what do you think the formula is?
2 times 9 plus 2.
2n plus 2. So 2 times 9 plus 2. Give us what?
20.
Right. 18 plus 2 is 20. What do you mean? You got me? Oh, okay, okay. I was working up with this, right? This is what I did. I said 7 plus what is 13? 6, right? And 13 plus 21 is what? 13 from 21? 8. I said, oh crap. The pattern ain't constant, you see that?
Yeah.
Is that plus 2 plus 2 plus 2 plus 2 coming out? But then, remember, watch now, remember the previous question? The previous question, you had to what? Add what? The white this with what? The black this. So then, I said, oh okay, what's here? So 3 plus 4, that's the formula. 3 plus 4 is 7. Right, 7 plus 6 is 13. 13 plus 8, 21. So then, what this was again? 91? This was 91. So 91, and this was what?
2 times
20?
5. 20.
So 91 plus 20, which back check is what? 111. Take down that for me. Camera on, by the way?
Yeah.
Yeah, because talking a lot, ain't not recorded. Good, so that's adding your plus and your equal. As you could tell, when you see total, remember, these can add up. Okay? Just add that to your thing. Should we even guess what's the number for this? It's 20. How do you know? Because these are 20s. Good. What was the formula for here again? 2 times 20 plus 2, 40 plus 2 equals 42. And what was the formula for here? Good, equals. Excellent. And what was our formula? Let's look at the formula now. N times N.
Plus SN.
Yeah, but you gotta put that in bracket, eh? Yes. Plus N plus 1. We gotta sum up these now. N times N is what? N squared plus N plus 1. You finish. Okay? You don't normally leave N times N by the sum. You have to put it squared. Good. And we done figure out this formula. Remember I told you, the earlier I figure out the formula, is better for you? I don't know. Sometimes CXC should be getting, okay, well, I guess you can't figure out the formula unless you see the pattern. That's what happened. That's why it will all be to the end. I don't just jump to the end when you come, we need to figure out the formula. I jump to the end means I watch my number patterns to see how we figure out things. So you think the formula for what here is? Okay, W plus B, good. But W has a formula and B has a formula. N squared plus N plus 1 plus 2N plus 2, sorry. Be careful if a minus was over here. The reason why I'm putting a bracket is just to let you guys know. If this was a negative or whatever, you have to be careful. Because it's plus, you could have gone straight across, okay? But you don't mess with minus. Never mess with minus. Nice. Right? So, you just simply write it back, drop the brackets, plus 2N plus 2. Join them up now quickly. Somebody join them up for me quickly.
Wait, join up?
Yes? Common terms, like terms. N squared 3N plus 3. Boom. Picture quickly. I think the question after this. There's one question after this. You have it? Oh, that wasn't a picture. There you go, this. Like this.
Stephen has 28 black discs.
Was it?
Yes. Stephen has 28 black discs and 154 white discs. And he wants
to make design 12. Explain why it is not possible for him to make design 12.
This is similar to the last question we had.
yeah.
Okay? Now, what was the formula for white disc? N
N squared plus N plus 1. N squared
plus N plus 1.
Yeah.
What design you talking about? Design what? 12. What was the one for black?
2N plus 2.
Let's see who can finish before me. Good. They say design 12. When design 12 gonna go in this. Let's see who finished before me. Let's go. 12 plus 12 squared is what? Uh-huh. 157.
Yeah.
Which is what? Add those two together.
So that's what 3, 8, 1. That's it. 180.
What's the ball? Stephen has so much? 28 what?
That is.
But how much you have to give?
26.
That's not enough, right? You have 154 white discs. How much you have here? You got too much. So then clearly, he's not gonna get you a choir because he doesn't have enough of the black and he got too much of the white. And that's not the ratio that we deal with. Okay? So that is proof that it's not possible to make the design. Because the design can't have so much white and it's still missing black to put in. Okay? That's the last question. God bless you. Thursday, we finish up the others and then we move on to some other things. Alright, so here we have the last of the series. We're on January 2025. We did May 2024, we did January 2024, we did May 2023, we did January 2023. Now we're on this year's exam, which went January. I don't know if any of you wrote it. This was given this year. The pattern is this. For those who have to draw, I'll advise you to get cracking right now. Where we have, how much dots do you see here, by the way?
4, 5.
Actually, 5. 1, 2, 3, 4, 5. Now, when I was originally watching this, I was saying 1, 2, 3, 4 lines and a square. But apparently, if you look at the table has, the first one has what? 8 lines. About that?
Yeah.
That means the square is counted. Each of these lines of the square is counted as 1. So it's 1, 2, 3, 4, 5, 6, 7, 8. Now, since this is here, this has to be this. So what is included? How many lines is included in the next one? Eh? If this and this is the same, how many more lines? 1, 2, 3, 4, 5, 6, 7 more. See that? Plus 7, remember that. How much dots is included? We had 5 here, so I will assume these are the same 5.
3 more.
So 3 more dots. We put that down here. So 3 more dots, 7 more lines. This is consistent. So this is from here to here. Again, the same 7 more lines and the same 3 dots. Okay? So when you're doing this down here, I know I have to. Good. So put your box. 1, 2, 3, 4, 7 more lines. That's the 4 of it. 5, it's the center. It's center between, okay? Oh, you can't get this go straight down, man. 5, 6, 7. And how much more dots is it? 3. 1, 2. Please, come more center. And it's an easy drawing to do, man. Only them who got to draw the whole thing are not difficult. Them who have the thing printed, clearly you only got a few things to do. Alright? Again, I realize some of you are making an attempt to draw because you work out getting the paper printed. That is a fallacy. That's a road that you're going down which doesn't make no sense. Okay? Make an attempt to draw because you're getting marks to do that. Or put it out in the exam there. No, you work it out now. Okay? You do that now. See if you can manipulate the diagram to make the pattern. Alright, as you're doing this, as you're writing, I'll read. The number of dots, D, and the number of unit lines that form each diagram, L, which is here, form a pattern. The values for D and L for the first 3 diagrams are written in the table below. Study the pattern of numbers in each row of the table. Complete the rows numbered, Roman numeral 1, 2, and 3. Now we have this. What is the first thing we think you should do? Somebody help me out, as I've been teaching this for a while now. What is the first thing we're going to do? Try to recognize what the pattern. So what is the pattern between 5 and 8?
3.
Add 3, there's no say 3. We're adding 3. And from here to here is what? Plus 3 again. So what thing will be from here to here? But the answer will be here? 14. Okay? What about from here to here? Add 7 at 7. 7 plus 22? Huh? 29. Simple to maths. Remember though, I told you before though, we can devise a formula. What do you think you could do to devise a formula? Can somebody lead me? What do we use this tree for?
Three multiplied by 1.
Very good. 3 multiplied by 1 gives you what?
3 and then
Plus 2 gives you 5. The plus 2 sign here. Plus 2. Yeah. No, 3 times 1 is 3, plus 2 to get the number. To get the number of that's 5. That's what you get. Right. Let's say if it's consistent. 3 times 2.
6.
I'm only here to people, you know. 6 plus 2. Good. So it's clearly 9 plus 2, 11. So we will correct 3 times 4, 12 plus 2, 14. Okay? Good. So then look at this 59. 3 times something plus 2 give me 59. So 3 times the number plus 2 equals, continue. 3n equals 59 minus 2. 3n equals, n equals, remember today, from today, you know that 3 can make it 57.
19 times.
Right, 3 times 92. Remember that, please. This is at the time when you learn new timetables. And that's why you without the calculator wouldn't have enough 3 But when you see it for the first time, remember that's how I learned it. Okay? Good. So we have 19 for here. So this has to be 19. So the whole number here then is 19. Okay? Now, the formula here, so we just establish that we just establish that the formula is 3n plus 2. Look at this one here now. Let's say 7 can work. 7 times 1.
7
But how do you get 8?
plus 1.
Plus 1. Remember it could be plus 1, plus 2, plus 3, plus 4, plus 5. It could even be what? Minus. Minus 1, minus 2, minus 3. Let's find what number. It could go above and come down. I will stay below and you add 1 to make it 8. Okay? That gives 8. Let's say it's consistent. 7 times 2. Plus 1. It's true. 7 times 3. Plus 1. So 7 times 4. Plus 1, 29. So 7 times 19 plus 1. 134 plus 1? Or the answer is 134. 7 times 19 is what? 133, I think?
Yeah.
Plus 1, 134. Am I catching the rules now? Am I catching the whole thing?
Yeah.
It's not going to be easy for everyone, all of them. One, they might say the hard one easy and try half it. But if it's all these easy ones, I'll knock them off quick, okay? Good. So what the formula is down here?
7n plus 1.
That's it for that question. That's it for that part of it. Pause. One of the diagrams in the sequence has 148 lines. Well, the reason why I keep it this way is because I want to see where the lines be. The lines is on this column here. Right? 148 lines. Calculate the number of dots in the diagram. Somebody start me off. You have 148 lines.
7n plus 1 equals
7n plus 1 equals 148.
Okay, nice. 7n plus 1 equals 148.
7n equals 148.
7n equals, and you have to add this 7 going to that, because 7 going to 14, 7 going to 7.
Yep.
So, 21 times. That means n over here will be 21. And this was 140. So what going to be the dots? Why? So the formula was 3n plus what? And this was 7n. Good. So 3n plus 2. 3 times
63 plus 65.
God bless. And you're finished with that question.